Well, hi everyone. I don't have another copy of this, and I actually didn't start the recording as I started doing the test. But let me just go through and explain what the process I went through. Give the equation of the line that is perpendicular to the line with y equals 5. So I drew y equals 5 right here, which then I saw that is a horizontal line and passes through the point negative 9, 12. So I made negative 9, 12 up here. And it's perpendicular, so it's a vertical line that passes through the x-axis at negative 9. So the equation is x equals negative 9. Now this next one, give the equation of the line that is parallel to the line with the equation 7x plus 2y equals negative 1 and passes through 7, negative 2. I solved for y so that it would be in slope-intercept form and found that the slope is negative 7 halves. Parallel lines have the same slope. So the slope of the line I'm looking for now is negative 7 halves, and it's passing through 7, negative 2. So I put the negative 2 in for y, the 7 in for x, the negative 7 halves in for m, and solved for b. Went through the process of doing that. And then I had this as a mixed number, and I changed it back to a improper fraction, and came up with the equation y equals negative 7 halves x plus 45 halves. So those two are just linear equations. Number 3, find each function value for this piecewise function, this following function here. F of negative 7, f of x equals x minus 1 when x is less than or equal to negative 1. F of x equals 3x minus 5 when x is greater than negative 1 and less than or equal to 3. And f of x equals x squared minus 3x minus 1 when x is greater than 3. F of negative 7. Negative 7 falls under here. It's less than or equal to 1. So I plugged the negative 7 in, got negative 7 minus 1, and that's equal to negative 8. F of 1 also falls into here. This is for x is greater than negative 1. Oh, it's negative 1. Never mind. It's 1. It falls here. It falls in this one. So I'm going to put 3 times 1 minus 5 here. That's 3 minus 5, which is negative 2. F of 3. I would use this one if x is greater than 3. Well, 3 is not greater than 3. 3 is equal to 3, and that still will go with that second function. So I'm going to take 3 times 3 minus 5. That's 9 minus 5 is equal to 4. Now, we are to graph this. I'm going to draw vertical lines. I'm going to draw one at negative 1. This is kind of a dividing part of my piecewise function. Negative 1 to 3. 1, 2, 3 is right here. So here's another division part. Okay? We're going to use this function on this side. We're going to use this function in between here, and we're going to use this function on this side. So let's just make some tables. And I'm going to go negative 1 of x. I'm going to write x minus 1 here. Negative 1, negative 2, negative 3. Negative 1 minus 1 is negative 2. Now, negative 1 gets the value, so I'm going to put a solid dot right there. Negative 2 minus 1 is negative 3. Negative 3 minus 1 is negative 4. So I'm going to write negative 1, negative 2, negative 2, negative 3, negative 3, negative 4, and so on. So it looks to me like we're following that diagonal of those units there for that part of it. Now, I'm going to do the middle part, x and 3x minus 5. And I am going to do negative 1, but I'm going to use an open circle for negative 1, 0, 1, 2, and 3. Negative 1 times 3 is negative 3 minus 5 is negative 8. 0 minus 5 is negative 5. 3 minus 5 is negative 2. 6 minus 5 is 1. And 9 minus 5 is 4. So I got negative 1, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. It goes all the way to that point, but this function gets to use the negative 1. This function takes it all the way to that. So it is important to have that open circle there. 0, negative 5. That's 8, 7, 6, 5 is right there. 1, negative 2. 4, 3, 2. Negative 2 right there. 2, 3, 4. Okay, I'm off one, aren't I? 1, 2, 3, 4, 5, 6, 7, 8. Oops, I'm off one. Okay. You're not there. You are. I'll put you there. You're not a part of this. Now 2, 1 is here. And 3, 1, 2, 3, 4 is here. And I'm going to use a solid dot for that one because the 3 is included. So this is the piece of that function. And now x and x squared minus 3x minus 1. We start at 3. It's going to be an open circle at 3. I'll go 4. I'll go 5. I might even go 6. It might get big though. We'll see. 3 squared is 9. Minus 3 times 3 is 9. So 9 minus 9 is 0. Minus 1 is negative 1. So I'm going to put an open circle at 3, negative 1. 4 squared, that's 16. Let me just write this down. 16 minus 12 minus 1. Now that's 3. 4 is 1, 2, 3. 5 squared, that's 25 minus 15. 3 times 5 minus 1. 10 minus 1, that's 9. 5, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we're going to run out of room from there. So it is a curve, this part of the parabola there. Now, the domain of this problem, from left to right. This will go left all the way. This will just keep going right. It goes up and goes right. In between here, it doesn't look like we have any gaps because we get to negative 1. We get to 3. So domain is all real numbers. Alright, this thing starts all the way down and comes up to here. It picks up here. There's some overlap here, but that's alright, and goes up to here. And then it comes down, and after 3, it picks up here. And I believe the range is all real numbers. The thing you'll need to watch, and I'm just going to say, just a for instance here, this isn't the way the graph looks, but what if this function went down something like this? If this, instead of this line being here, what if it went like this? Well, you go up to here, then it jumped down and come down to here, and then go back up. But right here, right in here, you've got a gap. And then you'd have to account for, and like I said, this is hypothetical. This isn't the way this one is, but I want you to be ready for a gap. you would go, what, negative infinity to negative 2. This is for the range. If this were the case, and this were the middle part, and not this. And then from, also negative 2 is included, so that should be a square bracket. And then it would pick up again at negative 1 and go to infinity. Okay? All right. Find all the values of x for which f of x equals g of x. F of x equals g of x, which means we got to solve this equation. Square root of x minus 6 equals 12 minus x. All right, let's get that square root out of there. So I've got x minus 6 here. That's 144 minus 24x plus x squared. Just do the... Alright, so I'm going to subtract the x. I'm going to add the 6. Add the 6. I got 0 here. I've got 150 here minus 25x here plus x squared here. X squared minus 25x plus 150 equals 0. Just changing it around a little bit. 1510. That factors, guys. That's x minus 15 times x minus 10. If you didn't catch the factors, you'll use the quadratic formula and you'll get this. So x minus 15 equals 0, or x minus 10 equals 0. So x is 15, or x equals 10. Well, 15 minus 6 is 9. Square root of 9 is 3. 12 minus 15 is negative 3. Uh-oh. Extraneous. Alright, let's try this one. 10 minus 6 is 4. Square root of 4 is 2. 12 minus 10 is 2. Let's keep that one. There's one solution there. Alright, don't know if you saw that, but 15 is extraneous. If you plug that in, you get negative 3 here. You get positive 3 here. Alright, number 6, domain. Okay, for this function, 3 minus 2x is greater than or equal to 0. It's under the radical. We've got to make sure it doesn't get negative there. I'm going to subtract 3 from both sides. I got negative 2x is greater than or equal to negative 3. By negative 2, x is greater than or equal to 3/2. There's my domain. This one, the denominator cannot be 0. X squared minus 1 cannot equal 0. So let's find out when it does, and we'll just say all reals except. So we're talking x plus 1 times x minus 1 equals 0. X plus 1 equals 0, or x minus 1 equals 0. Let's actually say not equal to 0. So x is not equal to negative 1 or 1. Can't equal those two. That makes the denominator 0. So we could write interval notation. Go negative infinity to negative 1. You go negative 1 to 1. And then go 1 to infinity. You could do that. Okay. Alright. C, square root of x minus 7 over x minus 11. Alright, well, x cannot equal 11. We know that, right? Also, you got that square root there. X minus 7 is greater than or equal to 0. So, x is greater than or equal to 7. X cannot be 11. It's greater than or equal to 7. So I'm going to write it like this. I'm going to go 7 included to 11 not included, and then 11 to infinity, and then we're good for that one there. Got two things to look at. In your numerator, you've got a radical, which you got to make sure you're not putting a negative value under, which means you got to have x bigger, 7 or bigger. The bottom, x can't be 11, so you got to make sure that's taken care of. All right, number 7. I honestly don't know what that thing looks like, so if I, there it is, looking for my calculator. All right, clear. I'm going to graph the absolute value. So I hit math. Some of you have asked for this. The absolute value. And then x. You know those. Minus 3 times the absolute value. Here it is. It's math under num. Go to num, and it's number 1 there. Absolute value, x plus 2. X plus 2. Let's graph that. Very interesting. Okay. Now, I do think that is negative 2, and I think that's positive 3. So, 3 makes it 0, negative 2 makes it 0. And those are the low points. Those look like minimums there. All right, minima there. So, this is decreasing. And then I also want to find the coordinates of this point here. So I'm going to go to second calc. It looks like a maximum. Number 4. Hit enter. It looks good for a left bound. Let's get over here for a right bound. Hit enter. I'm going to call that 0.5 and 6.5. That max, that relative max is 0.5 and 6.25. Now these are the open intervals on x. I guess that's not saying that, but I think we've done that enough that we should know that. So decreasing. Let's start with decreasing because that's from left. It's decreasing first. And on x, I'm going to go negative infinity to negative 2. Now, also from this point to here, which is 0.5 to 3, it's decreasing. Increasing. Let's go from negative 2 to 0.5. And then from 3 to infinity. All right. Number 8. Y equals, let's clear this one out, x cubed minus 3x squared minus x plus 1. And graph that. All right. I'm going to draw an accurate graph. One of the things I want to know, I'm going to answer all these questions first before I draw the graph. I got a relative max here. So I'm going to second calc, Let's get that max. Enter. 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 That max there is, I'm going to go negative 0.15, 1.08. 0.15, 1.08. Min. Second, yeah, we got a min here, so I'm going to go for that. Second calc. Min. Okay, left. Enter. Let's go right. Enter. Enter. 2.15, negative 5.08. Okay, now the zeros. 1, 2, 3 zeros. Let's get those plotted properly. Well, let's find them first. Second calc 0. I'm going to get the far left one. Left, right, enter. Negative 0.68. There's one of them. Second calc 0. Let me get over here a little bit. Left, right, enter. 0.46. Second calc 0. Let's get that last one. Alright. Left, right, enter. 3.21. Alright. Keep that graphs. I'll answer E last, but I'm going to try to make a good graph based on this. I want to see all these when you make your good graph here. So, negative 0.15, 1.08. So right there, I'm going to make sure it goes through that point. Also, the y-intercept is 1. If I put zeros in for x, it's going to be 1 there. I got that y-intercept there. Okay, that's the wrong side. Forget that point. Negative 0.15, 1.08, just barely right there. Very close to the y-intercept. It comes just a tiny bit above it and then comes back down. 2.15, negative 1, 2, 3, 4, 5.08. Let's put that right there. Let's mark the negative 0.68. There's a 0. 0.46. There's a 0. And 3.21. 1, 2, 3. 0.21 right around there. Okay. Now it comes down. Wonder what it is at negative 1. You can use this. Watch this. Second calc value. X equals negative 1. It's negative 1, negative 2. So I know that. So I'm going to wonder what it is at negative 2. Second calc value. Negative 2. Enter. Negative 17. Way down there. Okay. So let's come up here. Come through here. We bend it right there. Down till we get to here and bend it back up. And then we go up. Okay. So. Now. When is this function greater than or equal to 0? Alright. Looks like right here it's greater than or equal to 0, and after here it's greater than or equal to 0. It just keeps going up and up and up. So I would say from this 0 to this 0, greater than or equal to. So let's include those values. Negative 0.68 to 0.46. Can you see that? And then after this one, and that is, what's our 0? 3.21. From 3.21 and forever to the right, it's always above the x-axis, which means f of x is always greater than or equal to 0. Okay. Now, next page. Alright, I want to justify this one algebraically. F of negative x equals negative x cubed. Okay, we're just even odd or neither. We're going to see if f of negative x equals negative f of x, it's odd. If f of negative x equals f of x, it's even. So let's see if either of those happen. So I'm taking the x out and putting negative x in its place. Now negative times a negative times negative is negative, so I'm going to remove the parentheses, right? Negative x cubed. Negative 5 times negative x is positive 5x. Okay, I'm going to put a negative out here. Factor out the negative. I got x cubed minus 5x. So I got the opposite of the original. Okay? This is negative f of x. So f of negative x is equal to negative f of x. That means we have an odd function. This one, let's find g of negative x. I'm going to put negative x squared minus 4. That is equal to x squared minus 4, and that's the original function. That's g of x. Alright, those are equal. That makes this one an even function. Alright, now this one. Okay, h of negative x equals the cube root of negative x minus 4. That is not equal to that. If I were to factor out that negative 1, factor out a negative 1, I'd have x plus 4 here. And that would be the cube root of negative 1 times the cube root of x plus 4. I really don't need those parentheses anymore because I separated those. Cube root of negative 1 is negative 1, so I'm just going to put a negative here. Cube root of x plus 4. Now the negative cube root of x plus 4. Boy, if that were the same sign, I'd be calling this odd, but I'm not calling it that, and it's not the same, so I'm going to go neither there. And if you want to look at the graph, okay, if I'm looking at the graph, if I didn't know to do this, if I had trouble doing this, let me put a 3 in, and then math, and then number 5 here. X minus 4. Let's look at that graph. Okay. It is not symmetric over the y-axis. And it is not symmetric over the origin. I have a feeling if we were to shift it over here just a little ways, maybe we should see some symmetry there, but that's not what we're seeing. So we're just seeing it shifted 4 units right. Yep. Okay. So Remember the symmetries on that. Alright. What's this one going to be here? If you'll recall, I'm going to kind of lightly do this in green. And I go over 1, and I come up, go over 1. Remember the parent function for the step functions is up here, open circle, up here, open circle. Alright, I'm going to shift this 1 unit to the right and 1 unit up. Oh my goodness, look at that. That is right where it was. So this one, the transformation I put is the same as the original function, so it really doesn't change it. It just kind of moves things to places that were already there. So there's my graph of this. Now, f of 2.4. 2.4 minus 1 is 1.4 plus 1. The greatest integer function of 1.4 is 1. 1 plus 1 is 2. One 7/8. That is minus 1 is 7/8. And then plus 1. 1 7/8, that's 0. Plus 1, and that's equal to 1. 0.75. Okay. 0.75 minus 1 is negative 0.25. And then plus 1. Now negative 0.25, that actually goes to negative 1. And then plus 1 is 0. F of negative 2. So negative 2 minus 1 is negative 3. And plus 1. Now that is negative 3. When it's on an integer like that, it is just that value. Negative 3 plus 1 is negative 2. F of 3. 3 minus 1 is 2. And plus 1 is 2 plus 1 is 3. Okay, so this is all, if you'll notice, and we said that with our graph. The graph didn't change. This graph didn't change. So with that, now, chances are when you're doing this on a test, it's not going to be the same thing. Alright, I'm not going to use a calculator on this. And we've got to figure out the equation for these. Now, if you'll notice, this is the cubic equation. And if I go over 1, up 1, 1 to the third power is 1 from the middle. 2 to the third power is 1, 2, 3, 4, 5, 6, 7, 8. So this is not being stretched or compressed, but it is being flipped. So I'm going to write f of x equals negative, and it is being shifted 1 unit to the right, so I'm going to write x minus 1 and cube that, and 2 units down and put minus 2. This one is a parabola, so the parent function is f of x equals x squared. But we have shifted it one unit to the left, so let's go x plus 1 squared, and 1, 2, 3 units down, minus 3. It's not being flipped, so I'll leave that there. And 1 unit, let's see, 1 squared is 1. Well, I'm getting to 2 here. When I go 1 over, I should be at 1, but I'm at 2. So that means we are multiplying that by 2 and stretching that a little bit. Alright, so what's this one doing? Well, this is the square root function, isn't it? I got f of x equals square root of x, and we're going to, looks like we're flipping it over the x-axis. So that would entail negative square root, and then we're also moving it 1, 2 units to the right. So let's go x to the left, that's left, x plus 2, and 1 unit down, they'll go minus 1. And then if I look here, square root of 1 is 1, square root of 1, 2, 3, 4 is 2, square root of 1, 2, 3, 4, 5, 6, 7, 8, 9 is 1, 2, 3. So I think this will get it done for us here. Alright, that part you will not do with a calculator. So there you go, guys. The first part of the test, I'm going to give you this page. I'm going to say, answer these questions without the calculator, and then I'll give you this, and you can get your calculator out and finish this part. All right, take care.